Hey everybody, let's go over two integer sum on Neetcode's 150 list. So quickly, we're just going to mention that we're going to be using hash maps and std vectors. So just keep that in mind as we're going through it. You might need to be familiar with them, but yeah, a couple videos would be helpful before we dive into it if you don't know what they are already. So let's go over it. Just to describe the problem a little bit, in case you haven't seen it already, we are going to be given an input of a vector of integers like 1, 2, 3, 4, and it's going to be in non-decreasing order, which just means that the numbers are never decreasing, so it's not like this, and the numbers can be the same. So like 1, 1, 2, 3 is non-decreasing because they are never decreasing, but it's also not increasing because 1 and 1 don't actually increase, right? So yeah, and then after that we are going to be given a target value such as 7, and our job is to determine which two indexes add up to that target value. So in this case, we can see pretty easily that index 1 or 2 and 3 add up to 7, and we return this value. However, there's a little bit of a niche in this problem. We're going to be using an one index system, which really just means that instead of the indexes being 0, 1, 2, and 3, it's going to be 1, 2, 3, and 4. And that's really not important, as we'll see. It's just a little bit of a niche that they want in this problem, and it's going to be pretty simple to solve. So let's do an example of 1, 2, 3, and 5. And let's say our target is 8. So before I begin to explain the solution that's most optimal, let's go over a solution that probably a lot of people will think of first. And that is the solution that compares each and every element to one another. So they would start at 1, they would say 1 plus 2, let me get this out, 1 plus 2 is 3, not 8, 1 plus 3 is 4, not 8, yada yada yada. Eventually they would get to 3 plus 5 is 8, but notice how many operations they had to do. They had to compare 1 plus 2, 1 plus 3, 1 plus 5, 2 plus 3, 2 plus 5, and then 3 plus 5. So they had to go through that vector a lot of times. And this is not optimal, so our solution is going to only require us to iterate through this once. So we only have to pass through this list once to get those two indexes. And the way we're going to do it is we are going to subtract the target from the index value each and every time. And this might seem a little confusing, so let me just walk through it with an example, and then it'll slowly start to click. So let's start at element 1. 8 minus 1 is 7. That is not, or sorry, 8 minus 1 is 7. That is not in the list. Let me back up a little bit. So we are going to compare each element by subtracting the target minus the index value, and we're going to check if it's in this vector. So 8 minus 1 is 7. It's not in this vector. 8 minus 2 is 6. It's not in this vector. 8 minus 3 is 5. It is in this vector, but notice that we only index to 3 at this point. So we actually don't know it's in this vector yet. So we would have to go to 8 minus 5 at this index to get 3, and then we can notice that it's in the vector, and those are our two indexes. So the way we are going to keep track of those values is we are going to use a hash map. So let's kind of go to that place and let's initialize a hash map. So this is my very not accurate hash map, and let's go through it. So let's start at index 1, right? So we have 8 minus 1 is 7. We notice that that is not in the thing, so we add it to our map. We are going to say 1 in index 1. Remember, because we're using that one index system, so we are mapping this value and its index. Moving on, we go to 2. 8 minus 2 is 6. It's not in our map, so we are going to add it to 2. 8 minus 3 is 5. It's not in our map, so we add it. 3, and then 8 minus 5 is 3. However, notice at this point, we see that it is, in fact, in our map. 8 minus 5 is equal to 3. 3 is in our map. From this, we can access its element at index 3 and the element we are at to return 3 and 4. So that is how we are going to solve this problem. Just as a recap, in case I explained it like shit, we are going to index through each and every element. If target minus that value is not in this map, we are going to add it. So we started at 1, 8 minus 1 was 7, 7 was not in this map, we added this. Moving on, 8 minus 2, 6 was not in this map, so we added this. And then so on until we had 8 minus 5, which was 3, and then 3 was in the map, and we returned 3 and 4. So let's go up and code the solution. So let's put that explanation into code. So the first thing I'm going to do is I'm going to create that map. So initialize map, and I am going to call it map of integers my map, or let's be professional and call it num index. Let's iterate through that vector for int I equals 0, I is less than numbers dot size, I plus plus. We are going to say auto int equals num int dot find target minus numbers I. So in this line, we are kind of doing what we described in that video, which is subtract the target number from the value in the index we are in, and we are going to do that because we want to check if that value is in the map already. So if it is not equal to num_in.end, which means it's in the list or in the array or map, we are going to return target, or we're going to return the index of that value that we found, which is num_int target minus numbers I, as well as I plus 1, because we are dealing with that one index situation. If it's not in that map already, we are obviously going to add num_int target or num_int numbers I equals I plus 1. And that's it. And just to prove that it's all correct, there we go. Thank you. I'm so